Good morning to all my distinguished seniors, ladies and gentlemen. It's a privilege to chair a session with such kind of distinguished speakers on the panel. Let me get straight to the point. The best part about such a symposium is that almost all of us will echo the same thoughts, just with different words. Ironically, admitting that we all know the issue, know the resolution too, yet have been waiting, at least till now. This topic may sound shade technical, but in reality, it sits right at the heart of aerospace power. In future aerospace, materials are not supporting actors. They decide the plot. You may have a sleek design, you may have a great engine, you may have smart avionics, but if the structure is either too heavy, if the hot section cannot take the heat, if the coating degrades far too early, if the material life is uncertain, then the platform looks just amazing on paper, but it either fails or struggles when put to direct applications. And military world has seen enough of it already. Why does the topic matter? Let us simplify it. Every kilogram saved in an aircraft or a flying platform means one of the 5 things: more fuel, more payload, more range, more endurance, or just simply more survivability. And every increase in temperature tolerance in the engine nozzles, hot structure, thermal barriers, and high-speed application means better performance, better efficiency, and better durability. Let us be fair to ourselves. We have moved ahead as a nation. We are no longer in an era where advanced materials are discussed only in DRDO research labs or academic journals. We now have visible movement in actual aerospace programs. India's composite work in the HAL and ADA and DRDO-produced ecosystem has shown that we can reduce structural weight and improve efficiency in meaningful ways. CSIR-linked work on composite components have reported over 20% savings and around 25% weight reduction. Certain structural developments by ADA and HAL have shown that the material can tolerate around 200 degrees Celsius. But these have moved into production support with deliveries already made. That's important because it tells us that Indian material science is not just for publishing papers, it is finally begun to produce. At the same time, let us not fool ourselves. We have made progress, but we have not yet mastered the complete chain. We have islands of excellence, no doubt about it, but we do not have a full ocean of capability. The fact is, we are further ahead in airframe composites than we are in engine hot section materials. We are better at structural material substitution, but still struggling at full spectrum mastery of superalloys, single crystal blade, thermal barrier coating, high temperature ceramics, long life hot end materials, and production grade repair ecosystems. This is not negativity. This is plain reality. The aerospace has a nasty habit. It punishes self-congratulation. If material maturity is weak, sooner or later it shows up as delayed programs, lower serviceability, import dependence, restricted upgrades, or reduced wartime survivability. So let us not be impressed merely because something exists in the prototype form. That said, we should recognize that where serious capabilities have emerged. Single crystal blade technology has been developed by DMRL. Similarly, titanium and superalloy, as it was discussed by Dr. Kamath, some production facilities have been enhanced. There is a plant in Lucknow. In October 2025, they have inaugurated a facility which can produce 6,000 tons per annum of titanium. But no aerospace nation becomes powerful by importing the difficult material layers and then celebrating the final assembly. Where it shapes up is now let us come down to what I believe is one of the most important truth of the discussions today. Encouraging Indian private industry in advanced aerospace material is inescapable. As a great president of a nation said, read my lips. Participation of private industry is not desirable, not useful, not welcome, but simply put, inescapable. We cannot build a genuinely sovereign aerospace future by trying to preserve the strategic core indefinitely with the PSUs alone. A nation of India's size and ambition cannot rely on a narrow production model for technologies this complex and this critical. because there are few desirables which the private industry bring. Few are speed, process discipline, investment hunger, supplier depth, manufacturing competitiveness, and the willingness to scale. And frankly, in some cases, it also brings something else that is very badly needed, a fear of missing deadlines. We have to move beyond the mindset where private industry is treated as a peripheral participant. And let me say it with some humor, though the point is extremely serious. If we keep inviting private industry only after the difficult decisions are over, after the architecture is frozen, after the timelines are missed, and the budget has become nervous, then we are not building partnership. We are simply outsourcing our panic. So where do we go from here? We all know the achievable goalposts. There are few solutions. Firstly, we must move on from prototype success to production reliability. Secondly, India must build the full critical chain of all the materials and the material banks. Thirdly, every major platform should be judged not just by indigenous content percentages. This is a very fairly critical statement. Our product should not be judged by critical Indian content percentages, but by critical material independence. We need to source the rare earths. For that, we may need policy changes, major policy changes, and alter few environmental restrictions. So be it. There is no cost which compares to ensuring sovereignty. Fourth, we need a far tighter bridge between labs, manufacturers, users, and certification agency. And fifth, private industry must be brought into center much earlier, much deeper, and with much greater trust. It was reassuring to hear the harbinger of Indian Air Force future, Air Marshal Yalla Umesh, voice exactly the same thoughts of strategic relevance. There can be some bright lining because India today has stronger strategic intent, more industrial appetite, more serious private sector participation, with a clearer understanding that advanced material are foundational, not ornamental. The future belongs to nations that can combine lightness with strength, heat resistance with durability, innovation with industrial scale. We have the talent, the need, the demand. Now we must build the discipline to convert all that into hard reality. Because in the end, aerospace power is not built by mere announcements and symposiums. It is built by materials that work, factories that deliver, and systems that scale.